Hey guys, welcome to this YouTube video. In this video, we will discuss about the 0-1 knapsack problem. So let's consider a case where you're given an eraser whose value is 6 rupees and the weight is 1 unit, whatever. And now I give you a pen whose value is probably 10 and the weight is 2 units. Okay, this is the weight, this is the value. And then finally, I'll give you another object. And let's say the value of this object is 12 and at the same time the weight is 3. Now the question is, you have to select any items. You can select all 3 or whatever, but I'll keep a capacity. You should not, your weight should not exceed above this 5 units, and at the same time you have to maximize the value. So you have to maximize the value and you have to subject it to a constraint that the weight is less than or equal to 5. So how would you do that? So if you guess that I'll take this pen and this pencil, then you'll get a maximum value of 22. At the same time, your weight is 5. So which is less than or equal to the given weight constraint. So let's formalize this problem. So these are the 3 objects that are given to us: an eraser, pen and a pencil, whose values are given and whose corresponding weights are given. Now we want to maximize its value. At the same time, we have to hold it to a constraint, that is the weight should be less than or equal to some x value. Now how do we solve this problem? So how do we go about and solve this problem? So for simplicity, I'll name it A, B and C. Now let's say we have objects A, B and C. Now what we have to do is, we'll take an initializer, that is iterator, and initialize to the first position, to the object A, and now we'll take a decision. And our question is, shall we include this particular element or object A to our knapsack or not? Now if we include it, there will be a cost and weight associated. So what will happen is, our value will improve to 6, since that is the value associated with object A. But our weight capacity, which was 5 initially, will now reduce to 4 because the weight of this particular unit is 1. Now what if we don't include it? Then we'll be left with a value 0. Our capacity will remain as such. Now we'll just increment our pointer so that it points to the second object. Now in the second object, if we include it, we'll get a value 16 and our weight will reduce to 2 because the value associated with object 2 is 10 and the weight associated is 2. We'll reduce the weight and add the value. So if we don't, we'll get the 6 by 4. The value will remain as such, weight also. Now for this, the value will be 10 and the weight 3, and if we don't decide not to include it in our knapsack, then it will remain as such. This is not including, this is to include. So left side is to include, the right side is not to include. Now what we do next is, we'll increment the pointer again. Now I will point to the third object, which is C. Now if we include it, what happens? But before we include it, now we have a problem. That is, our third object requires a weight of 3 units, but we only have 2 units. So can we include this in our knapsack? No. So this will stop. And next, if we decide not to include it, it will remain as such. Now if we decide to take the third object, we have the capacity, we have 4. The object 3 has a weight 3. So if we include it, we'll get 18 and the capacity will be reduced to 1. If we decide to do nothing, it will be 6, 4. If we decide to take it, then our value will be 22 and the weight will become 0, 3 and 3. So if we decide not to do anything, we'll get 10 by 3. If we take it, we'll get 12 and remaining weight will be 2. If we decide to do nothing, get 0 or 5. Now here's the important part that we have to see. Now after doing this, we have to calculate the maximum within 2 nodes. So here the maximum is 16. So it will go to the nodes, and here you will get the maximum is 16. And here the maximum value that you can get is, you have to compare with 18 with 6. 18 is higher, so 18. So here if you compare, 22 will be higher, and in this case 12. So if you bubble it up to the next level, to the top level, here we'll get the maximum value to be 18, and in this case we'll get the value to be 22 and 18. So finally, if we compare and find the maximum element, it will be 22. So that is our solution. If we include B and C, we get a maximum value of 22. Alright, let's start to code this out. So I defined this preprocessor directives already, and let's go ahead and define our function. So before we do that, let's declare in global space our question, that is the values given in the question. So weight is 1, 2, 3, and our value matrix, value array will contain the values as 6, 10, and 12. So, and also the size int n will be 3, since there are 3 elements. So the function will start with, it will return an int value, that is the maximum capacity that can be taken into the knapsack, and the name I'll call it as ks for simplicity, and let's pass in our iterator I and the capacity int c. Now what we have to do is, we have to define the base conditions. So base condition is if I is equal to the end, or if the capacity is less than or equal to 0. What you have to do, we just have to return 0 then. There can be another case where one particular element is very large and that cannot be taken into our knapsack, but we don't want to stop there, we want to go past that. So to write it, if the capacity is less than the current weight value, then we don't have to worry, we just have to return the knapsack just by incrementing our iterator to the next element if it is existing. So I plus 1, and the capacity will remain as such. So after that, if all these conditions are met, then we can go and return the maximum of, let's say we are accepting it. Now if we accept it, then we have to add the value. So value at that particular iterator plus the knapsack of I plus 1, and the capacity will also be reduced if we accept that particular element. How much it will be reduced is given by weight matrix at that particular iterator point, and then we have also another choice where we can refuse to take that particular element. So if we do so, we just have to increment our pointer, and the weight will remain as such, or the capacity in this case. So that's the end. I hope I've done everything rightly. Now I'll define the main function. So in the main function, what we have to do is, we have to print it. I'll just call the function ks, and here the I will be 0 and the capacity was 5. So let's see if we get the answer 20. Yes, we got the answer 20. Fine. Alright, so this is about our code.